In this video, I am going to discuss about the insertion sort algorithm. It is a simple sorting algorithm which sequentially sorts each item in the final sorted array. Insertion sort is a sorting algorithm which sorts an array by inserting each element in its correct position in a sorted sublist. Basically, it works by comparing each element with the previous elements and then moving the element to its correct position by shifting the larger elements to the right. And this insertion sort algorithm works similar to the sorting of playing cards in hands. So it is assumed that the first card is already sorted in the card game. So now we select the second card, which is an unsorted card. So if the selected unsorted card is greater than the first card, it will be placed at the right side. If it is lesser than the first card, it will be placed at the left side. Similarly, all unsorted cards are taken and put in their exact place. So the same approach is applied even in insertion sort algorithm. So the idea behind the insertion sort algorithm is that first take one element, iterate it through the sorted array. So although this insertion sort algorithm is very simple to use, it's not appropriate for large data set. So here I am going to provide a detailed explanation of insertion sort algorithm along with an example, pseudocode and time complexity analysis. And before we move on to the example, let's discuss three important points under algorithm overview. So this insertion sort algorithm start with only the second element of an array. So this algorithm would start making the comparison right from the second element of an array and compare it with the elements before it. And the second point is insert the element into its correct position in the sorted subarray to its left, and repeat this process for each element in the array until the entire array is sorted. So here the example is given. So this example array contains n number of elements. Here the n value is 6. So now before we solve this example, I just want to discuss few steps to solve it first. So as we mentioned, as I mentioned before, like here this insertion sort algorithm should start with the second element of the array. So the loop should start from, so here if we check the second element, is the second element index here is 1, the index of an array for the second element is 1. So our loop should start from 1 here. So our loop would iterate right from 1 till n minus 1. It's going to be the right iteration, and when it comes to n, it would violate the condition and it would come out of the loop. So it's right from the 1 until n, the loop is going to get iterated. So once the k value is set, the next step is create a variable called a temp. Under the temporary variable, you are going to store array of k value, and then the next step is create a j pointer, and the j pointer should point k minus 1. If k value is 1, j pointer should point 1 minus 1, which is 0. So it would be pointing the 0th index, the j pointer. So after setting up the temp variable and the j pointer, the next step is we are going to use one more loop inside the for loop, in which two conditions are given. One is we have to check whether the temp variable is lesser than or equals to array of j, and the second condition is our j pointer would be pointing the index, right? So that index must be greater than or equals to 0. These are the two conditions. Both of these conditions should get satisfied. Once satisfied, it will enter inside the while loop, and there are two statements inside the while loop. One is placing the array of j element to array of j plus 1th position. That is one step. Once the element is written to j plus 1th position, we are supposed to decrement our j pointer. When the condition is not satisfied, it has to come out of the while loop and it would execute this statement. Finally, in the place of array of j plus 1, it is supposed to write the temp variable. We are supposed to follow these steps, and these two statements are coming inside the while loop. So these are the steps we are going to follow while solving the example. So let's start solving the example now. Very first step is our k value is going to be 1. So when our k values equals to 1, we are supposed to set the temp variable as well as the j pointer. So our temp is going to be array of k, which means array of 1, because our k value, our current k value is 1. So in the place of array of 1, 52 is there. So we are going to store the value 52 under the temp variable. So once the temp variable is set, we are going to set the j pointer as well to k minus 1th position. K is 1, so 1 minus 1, which is going to be 0. So now j pointer would be pointing 0th position, and under the temp variable we have stored the value 52. Now check for the condition, check whether the temp is lesser than or equals to array of j. So our array of j value is j value 0, so array of 0 value is 30. So check now whether the temp is lesser than array of j. No, the temp is not lesser than array of j, so we won't be able to execute these two statements, right? So directly it will go back again and increment the k pointer. Now the k value would be 2. So when k value, after setting up the incrementing the k value, again under the temp variable we are going to store now is array of k, which is array of 2. Array of 2 is 29. So we are going to store the value 29 under the temp variable, and j value is going to be k minus 1, which is 2 minus 1 is 1, and array of j values array of 1, array of 1 is 52. I will copy down the array again, the elements 30, 52, 29, 87, 63 and 27. These are the elements. Zero, 1, 2, 4 and 5. So now here during the second iteration, under the temp variable 29 is stored and j is pointing 1, and this is our j. Now check for the condition. So after setting up the temp and j, check for the condition whether the temp is lesser than j. Check, yeah, this is our temp and this is our j. Yes, our temp is lesser than j only, so the first condition is satisfied. The second condition is j should be greater than or equals to 0. Here the j value is 1. Yes, j is greater than or equals to 0 only, so the condition is satisfied. It would enter into the while loop. So here again two statements we are supposed to execute. The first one is array of j should be written in the place of j plus 1th position. So first we will perform the first statement which has been which is there in the while loop. So write array of j value, or array of j value is 52. This 52 must be written in j plus 1th position, and rest all will remain in the same position. Once written, the next step is decrement the j value. So our j value was pointing 1. Now if you decrement it, our j would be pointing 0. So now j is pointing 0. Since it is a loop, again we are supposed to, since it has been given inside the loop, again we are supposed to check whether the temp is lesser than array of j. So now array of j values, before it was 52. After decrementing our j, now the current array of j value is 30. Check again whether the temp is lesser than array of j. Yes, the temp is lesser than array of j. Again we are supposed to write an array of j value to the j plus 1th position. So this is our j value. So to the j plus 1th position also we are supposed to maintain the same value 30 and write all other elements in the same position. Once written, we are supposed to decrement our j pointer. So j was initially pointing 0. After decrementing j, our j value would become minus 1. Now check for the condition again whether the temp is lesser than array of j. No, because there is no array of j value, because there is no more element after this 30. So there is no array of j value. So the first condition is not satisfied. If you check for the second condition also, the j value is not greater than or equals to 0. So both of these conditions got violated. So it would come out of the loop and it would execute this statement. In the place of array of j plus 1, we are supposed to write the temp variable. So, array of j plus 1th position is our j value is -1, -1 plus 1 is going to be 0, which means in the place of 0th index we are going to write the temp variable. Our current temp variable is 29 here. So, in the place of array of 0 I am going to write 29. Remaining all other elements would be retained in the same position. So, now the second iteration got over. Now, we are supposed to increment our k value. Now, the k value would be 3. So, k value now is 3. When the k value is 3, our temp is going to be array of 3. So, here array of 3 value is 87. So, under the temp there would be 87, and the next step is set up the j pointer should be k minus 1, our k value is 3. So, our j would be pointing 3 minus 1, which is 2, and then you have to fetch out the array of j value. Our j value is 2, so our array of j value is in the second position, array of 2 is going to be 52. Right. Now, the next step is after setting up the temp as well as the j value, we are supposed to check for the while condition. So, the while condition is we have to check whether the temp is lesser than or equals to array of j. Our temp value is 87 here, array of j value is 52 here. So, the temp value is not lesser than array of j, it is greater. So, like it would come out of the loop, the while statements would not get executed. So, the next step is increment our k value to 4. Now, the k value is 4. When k value is 4, set the temp value again. Under the temp variable, store array of 4 value. Array of 4 value here is 63. Set the j value is k minus 1, our k value is 4, so j value would be 3. Next is fetch out the array of j value. Array of j is array of 3. In the place of array of 3, we have 87. Now, copy the array again. Now, the temp is pointing 63. J pointer is pointing 3. Now, you check whether the temp is lesser than array of j. Yes, temp is lesser than array of j. If so, we are supposed to write j value to j plus 1th position. 29, 30, 52. This is our j value. This must be written in j plus 1th position as well. 87, then 27. So, once written, we are supposed to decrement the j pointer. J was pointing 3, now j would be pointing 2. After decrementing j value, array of j also would be changed. So, now in the place of array of j, there is 52. Now, check again whether the temp is lesser than array of j. No, temp is not lesser than array of j. So, it would come out of the loop. After coming out of the loop, it would be executing this statement. Array of j plus 1 equals to temp. So, this is our j. So, in the place of array of j plus 1, we are supposed to write the temp. So, in the next step, write the temp value. Our current temp value is 63. So in the place of array of j plus 1, I am writing 63, then 87, 27. So now fourth iteration is completely over. Let's move on to the fifth iteration. Increment the k value to 5. So when k equals to 5, the temp value is going to be array of 5. So temp equals to 27. So now j value should be k minus 1. So the j pointer would be pointing 4th index. K is 5. So 5 minus 1, 4. And array of j value is going to be array of 4, which is 87. The next step is compare temp and j. I will write again. Then 27. So now the temp is under the temp value. We have stored 27 and j pointer would be pointing 4th index. Now check temp and j. Yes, temp is lesser than array of j. So if so, we are supposed to write j value to j plus 1th position. $30, $52, $63, $87 is our j. We are supposed to write in j plus 1th position as well. After writing it, we are supposed to decrement our j. So now j value would be j pointer would be pointing 3rd index. So now array of j value would be changed. So array of j value is going to be 63 now. Check again now whether temp is lesser than array of j. Yes, temp again is lesser than array of j. So again write j value to j plus 1th position. This is our array of j value. We are supposed to write this array of j value to j plus 1th position as well. Once written, we are supposed to decrement our j. So j pointer would come here. Now again array of j would get updated. Array of j value is going to be now 52. Check again whether temp is lesser than array of j. Yes, temp is lesser than array of j. Again write j to j plus 1th position. So 29, 30, 52. This is our array of j value. Now write in the place of j plus 1th position as well. Once written, decrement j pointer. So now j would be pointing 1st index. So array of j also would be updated, which is 30 now. Now check again, temp is lesser than array of j. Yes, temp is lesser than array of j. So again write j to j plus 1th position. After writing, we are supposed to decrement our j, so now j would be pointing 0th index. Now check again, array of j is lesser than temp. Now array of j value is 29. Yes, 29 is lesser than temp value, temp value is lesser than 29 only. So again write j value to j plus 1th position. After writing, we are supposed to decrement the j value. J value was initially pointing 0. Now after decrementing it, our j value should be minus 1. Now check again temp and array of j. There is no j value because it got over. There are no more elements after this. So there is no j element. So here the condition, the first condition got violated. Even the second condition also got violated because our j value is minus 1 only. But here the condition is our j should be greater than or equals to 0. So both the condition got failed. So it would come out of the loop and this statement would get executed. Array of j plus 1 equals to temp. So in the place of array of j plus 1, we are going to write temp. So j value is minus 1 plus 1 is 0. So in the place of 0th index, we are going to write the temp value. The temp value, the current temp value during the 5th iteration is 27. So we are supposed to write 27 in the place of 0th index. The rest all will remain in the same position. So the 5th iteration is completely over. So when you increment it, now k value would be 6. So check here, if you look at the condition, in the for loop, k value should start from 1 till n only. So when it is n, it should come out of the loop. Till n minus 1, it is going to be the right iteration. So when it comes to n, it's going to be it is going to exceed the value because there is no 6th index over here. So all the elements got over here to compare. So now it would completely come out of the loop, and whichever is the final array is going to be the final sorted array. So this is how the insertion sort algorithm works. So in the upcoming video, like the detailed the pseudocode and the time complexity analysis would be discussed. Thank you.